Alright guys, today we're going to be talking about the ratio test. This is just another test for series to determine if they converge or diverge. And what we're going to do is we're going to take the inside of our series and we're going to add 1 everywhere there's a K or an N or whatever our letter may be. And we're going to find the ratio of a sub n plus 1 over a sub n, absolute values. And if that number, whatever it is less than 1, then it converges. If it's greater than 1, it diverges. And if it equals to 1, it's inconclusive. So the way we're going to do that is we're just going to start out, and it's the limit as n goes to infinity. So we're going to do the limit as k goes to infinity of 3 to the k plus 1 over k plus 1 squared. Everywhere there's a k, I'm going to insert a k plus 1. Divided by this. Well, if I divide by this, I'm really just multiplying by the reciprocal. Okay, and then I simplify this inside. Well, that's the limit as k approaches infinity of 3 to the k plus 1. If you remember your rules for exponents, when you're adding exponents, that's the same thing. I can rewrite that as 3 to the k times 3 to the 1 times k squared over k plus 1 squared times 3 to the k. I simplify anything that I can. I see that my 3 to the k's cancel out, and then it's whatever I happen to have left. Well, what I have left is the limit as k goes to infinity of 3k squared over k squared plus 2k plus 1, if I go ahead and pull that out. The limit of that, as k goes to infinity, the degrees are the same, so it's the coefficients. So it's just 3. Now, if you look at your rules, 3 is greater than 1, so it's going to diverge. Okay. Let's do another one. This one I'm dealing with an n, so I'm going to do the limit as n goes to infinity of n plus 1 squared over 2 to the n plus 1 times, and I'm just timesing by the reciprocal, 2 to the n over n squared. So that's the limit as n goes to infinity of, I'm just going to leave it n plus 1 squared for now, times 2 to the n over 2 to the n times 2 to the 1 times n squared. My 2 to the n's are going to cancel out. So I'm left with the limit as n goes to infinity of n squared plus 2n plus 1 over 2n squared. Again, my degrees are the same, so it's just my coefficients, which just so happens to be 1/2. Now 1/2 is less than 1, so that's going to converge. Okay, let's keep on going. Let's do the next two. Limit as n goes to infinity of, everywhere there's an n, I'm going to put an n plus 1, so n plus 1 times negative 3 to the n plus 1 over 4 to the n plus 1 minus 1 times the reciprocal, 4 to the n minus 1, n times negative 3 to the n. Okay, so I'm going to rewrite this. That's the limit as n goes to infinity of n plus 1, that's negative 3 to the n times negative 3 to the 1 times 4 to the n minus 1 over, now my goal is to make stuff cancel, so I'm just going to rewrite this as 4 to the n minus 1 times 4 to the 1, because if you added those together, you would get n plus 1 minus 1 times n times negative 3 to the n. And let's see what cancels. Negative 3 to the n's gone, 4 to the n minus 1 is gone. And then it's like, well, what's left? So that's the limit as n goes to infinity. I'm going to pull my whole numbers kind of to the front, and that's negative 3 fourths n plus 1 over n. Well, the limit as n goes to infinity, I'm looking at my degrees again. And I can actually, remember your limit rules, you can pull this coefficient out. I could rewrite that as 3/4. Why is it a positive? Because it's in absolute values, times the limit as n goes to infinity of n plus 1 over n. Well, this goes to 1, so it's just 3/4 times 1, which is 3/4, which is less than 1. Because it's less than 1, it's going to converge. And the last one I'm going to do on this video, and then I'll do an additional video, look for ratio test number 2. Let's do another one, is limit as n goes to infinity of n plus 1. Be real careful with this one because you got to put an n plus 1 everywhere there's an n. N plus 1 over 3 to the 1 plus 3 to the n plus 1. Now, that one's a little tricky. Remember, just basically you're timesing by the reciprocal. Okay, so I'm going to rewrite it. That's the limit as n goes to infinity. That's n plus 1 to the n times n plus 1 to the 1 times, I want to do this, 3 to the 1 plus 3n over, now remember, this is, if I go ahead and distribute that out, I'm just going to distribute it out right here, 1 plus 3n plus 3. You want this term to cancel out. So can I rewrite that as 3 to the 1 plus 3n times 3 to the 3 times n to the n. So that's going to be, let's see what cancels. These cancel. I think that's about it. So let's see what we have left. We've got the limit as n goes to infinity of n plus 1, basically to the n plus 1, that did not go away, over 27n to the n. Now if you look at your degrees, just look at this one here. Regardless of what I put in there, as n goes to infinity, just say I'm at 100. This would be 101 on the top over 100. The degree of the top is always going to be bigger than the degree of the bottom, regardless of what I'm looking at. So that's actually going to go to infinity, or I could say does not exist. Infinity is definitely bigger than 1, so therefore it diverges. Okay, this video is going to stop and just pick up with the next one. It's ratio test number 2.